topic is magnetic field due to a long solenoid. Here you have to consider a solenoid. Let us draw the diagram like this. Let I be the current flowing through the solenoid. A uniform magnetic field can be produced only inside the solenoid. Outside the solenoid, the magnetic field is 0. To calculate the magnetic field intensity inside the solenoid, let us consider a point O. Around the point O, we have to imagine a rectangular closed loop. The length of the closed loop, which is taken as L, and the breadth of this rectangular closed loop, which is taken as B. So PQRS is the imaginary closed loop. So according to Ampere's Circuital theorem, we have to write integral P to Q B dot dl plus integral Q to R B dot dl plus integral R to S B dot dl plus integral S to P B dot dl, which is equal to mu 0 times the total current. Here N be the number of turns, then we can write it is mu 0 N I. So next, if we take this side PQ, this is same as the direction of magnetic field. So that here the angle theta is equal to 0. The value of cos 0 is equal to 1. And at the same time, the second case, the side QR is perpendicular to the direction of magnetic field. So that here the value theta is equal to 90 degree, cos 90 is equal to 0. RS lies outside the solenoid. Outside the solenoid, the magnetic field is 0. Therefore, here also B is equal to 0. Then the side S to P, it is perpendicular to the direction of magnetic field. So that value theta is equal to 90 degree, cos 90 is equal to 0. So that here we have to write integral P to Q B into dl. All other three cases it is 0. So that we can write it is equal to mu 0 N into I. So here the left side will get the value B into L, which is equal to mu 0 into N. Here we know that N be the number of turns per unit length. That is small n is equal to the total number of turns by the length of the conductor. From this equation we can write n is equal to n into L. Therefore n L into I. This L and L cancel. The magnetic field B is equal to mu 0 N into I.
If you found this video helpful, please like, share and subscribe to the channel. See you next class.